Hello, everybody, and welcome to this session for Cloud Lunch and Learn. I'm Dwayne Netwick. I'm your moderator today, and with me today is Rolf Schuten. He is going to provide you with a presentation on from Chaos to Optimum with Azure Chaos Studio. So enjoy, have a great time. If you have any questions, please feel free to comment, and we will address those during the session or after the session. So without further ado, I am going to turn it over to you, Rolf, and have a great session.
Thank you, Dwayne. Let me get my presentation up. So getting started right away. Thank you so much for joining my session from Chaos to Optimum today. My name is Rolf Schuten. And today I would like to tell you something about Microsoft Azure Chaos Studio and how to improve application resilience using this Microsoft service. Making sure you see my screen. First, let me introduce myself. This is me, obviously, working in the Netherlands as a cloud advocate at Sageka. I'm also a recent Microsoft Azure MVP and a Microsoft certified trainer. Like most people, I am to be followed on social media. As long as Twitter remains in existence, you can find me there as well. And as many people in the IT industry, I write blog articles. And the session today is actually something that started with a blog post. And you can do the full step-by-step guide to create the demo environment I'm using today by following one of those blog posts out there. I host a podcast around Azure called Azure Talks. If you like Azure, you can follow it. I would like that if you followed it, but nothing if you don't. Today we're not going to talk about me or my podcast. We're going to talk about Azure Chaos Studio and chaos engineering. Today I'd like to start with some theory and the history or beginnings of chaos engineering. And then I would like to tell you a little more about Azure Chaos Studio. After that comes the fun part, the live demonstration in which we will intentionally introduce errors in our solutions. So let's start at the beginning and go through the actual reason we need resilient solutions. We all have to deal with service levels in our profession. And back in the days when I was a service manager, the service levels were extremely important to me in conversations with customers. The business part mainly has to do with the degree of business criticality, and organizations know that failure can lead to a loss of profits or stopping of critical processes. And an obvious example is for a nursing home, they cannot view patient data during a medically critical situation, something that should never happen because of the impact and consequences. Hence, these solutions must guarantee a certain availability and resilience. And our businesses, health, safety, rely on applications and systems that actually will fail in the end. And on this slide, you see several availability levels translated into the amount of unplanned downtime per year. And to meet that agreed availability levels, we must design the resilience of solutions in such a way that we can meet them. And the moment we step away from the paper truth and also look at the solution architecture and technology, it quickly becomes more complex. When we delve deeper into the meaning of availability levels, we have to consider that availability levels of the underlying components can weaken the total solution. And this is especially true as complexity of application and infrastructure landscapes keep increasing. So suppose you purchase a virtual machine in Azure, which has an availability level of, let's say, 99%. That means that we consent to a possible downtime of 3 days and 15 hours a year. And if we would decide to make it a clustered solution existing of 2 virtual machines, for, let's say, to realize a high availability solution, we can get these levels up to an availability level of 99.99%. And we would then consent to a possible 52 minutes of downtime a year. However, there is a catch which has a strong influence on availability levels. The load balancer, which is required to realize the high availability solution, has its own availability levels. And in this case of the Azure load balancer, the standard SKU has an availability level of 99.99% as well. As a result, we do not achieve a total 99.99 availability, but we have to multiply them with each other, which results in a 99.98 availability. In this case, we consent to 1 hour and 45 minutes downtime a year, and that doesn't seem like much, but we're talking about doubling the amount of possible downtime. And the more components we add with our own service levels, the more impact this has on the resilience and reliability of the total solution. So think of networking, firewalls, databases, compute. They all individually affect the whole. And therefore, it is not logical to test all individual components separately from each other. The components within the total solution jointly determine the resilience and reliability as a chain. And this applies to both the applications and the infrastructure. Traditional testing methodologies have been around since the inception of software development, and the way they are mainly based on pre-organized phasing of the software testing lifecycle. They consist of one-way processes from software debugging to integration testing to host configuration, the underlying infrastructure, and so on. And this is often followed by functional testing with a new release of software, supplemented with possible use acceptance tests. And the various tests are often spread over different teams and specialists, and it does not all benefit the speed and agility of software development. But from a resilience perspective, this also does not guarantee the reliability or robustness of the total solution. So traditional testing is not enough anymore. And we must realize that breakdowns are inevitable. And instead of leaving breakdowns to chance, we are driven to consider built-in resilience nowadays. Relying on availability level of infrastructure components, a system or application must be designed as thin as possible to be just as resilient as the underlying infrastructure. And failures are inherent to complex systems and will cause downtime unless tested for. And this is exactly where chaos engineering steps in. Chaos engineering disciplines developers to build confidence in systems and break systems on purpose. Breaking them on purpose so weaknesses can be found and fixed before they break when the least expected. Similar to pen testing, chaos engineering aims to detect weaknesses so they can be fixed before actually happening. So its goal is not to cause damage, but to prevent this in production scenarios. And on the screen, you see the logo of Netflix. Netflix was the first in 2011 to recognize that development models needed a change. Their intent was to move from a development model that assumed no breakdowns to a model where breakdowns were considered to be inevitable, driving developers to consider built-in resilience to be an obligation rather than an option. And to support this, Netflix developed Chaos Monkey that same year and released it in 2012. And in that same year, the concept of chaos engineering was officially born. Chaos engineering are thoughtful, planned experiments designed to reveal weaknesses in our systems. And yes, chaos engineering is basically breaking your systems on purpose, but with surgical precision. Only so that weaknesses can be found and fixed before they break, when the least expected. And this can be done by breaking your systems on the application level, causing host failures, simulating resource attacks on the CPU or memory, networking attacks, dependency and latency experiments, or even total region attacks. When we look at the general process of chaos engineering, we start with the steady state. And the steady state is the normal behavior of your system. It is important to know the value range of a healthy state, because next to the steady state is the hypothesis, which are your what-if scenarios, like what if the load balancer from the previous example I just mentioned breaks, or what if that virtual machine stops? So designing experiments are about picking a hypothesis, scoping your experiment, identifying your metrics, and of course, notify your organization. Designing your experiment as close to production, but make sure you have an emergency stop. And also minimize what we call the blast radius, as you don't want to create a catastrophic incident. And obviously, verify and learn means running the experiment, for example, through a canary deployment, and learn on topics like time to detect, time for notification and escalation, self-healing kicking in, recovery time, etc. And last but not least, you fix and improve your solution, prevent it will ever happen again, for the least in the production. And I mentioned it that, for example, using a canary deployment model, a deployment model that works well for chaos experiments is actually a canary deployment model, in which you make a new version available to a subset of users, as shown in the image on the slide here. And in this way, you limit the blast radius, and you can always guide users back to the previous version. You must coordinate all these topics with the business, because the last thing you want is to be disruptive to production. After all, chaos engineering is there to prevent chaos in production. So having a meeting with the business owner, discuss the possibilities and impossibilities, and agree that you will periodically hold a retrospective with each other to continuously improve the process. Also, I would like to address that it is important to never blame anyone during this process, but rather hold a growth mindset, if you will. Once again, chaos experiments don't cause the problems, they reveal them. And to support chaos engineering, Microsoft announced Azure Chaos Studio on the 2nd of November 2021, which was during Microsoft Ignite. And it is Microsoft's service to improve application resilience and disruption. It is a fully managed service, which doesn't require you to do any management or maintenance. It is deeply integrated in all the sweet things that we like in Azure. We can use Azure Resource Manager and leverage ARM templates, Azure Policy, role-based access control, etc. And Azure Chaos Studio comes with an expanding fault library, which you can use to actually design your experiments. And I would like to show you some of those faults that are actually in that library. So when we're going to the Learn website from Microsoft, which was docs.microsoft.com earlier this year, they have on their documentation website the fault library. And it is an extensive list of all the types of faults and actions you can run by using Azure Chaos Studio. And I will explain the different fault providers in just a bit. But you can see here in this article all the different types of faults that you can run to, well, let's say virtual machines. So we have something that is called a kill process within a virtual machine. But we're also leveraging all kind of types directly into Azure native tools like key vault deny access. We can mess around with network security groups. We can even introduce faults using Chaos Mesh within our Azure Kubernetes clusters. And you can run faults in sequence or in parallel at time delays between the different faults and actions. You can run faults to group target resources across regions. And Microsoft promised to keep adding new faults that align to the failures users want to replicate in Azure and beyond. It provides controlled chaos where you can easily stop an experiment and roll back to the fault being injected to avoid having more impact to an environment than originally intended. And how it actually works is that the fault and action library is the starting point for building your experiments. It is easy to configure the areas from the library to your liking and your taste, and this can be done from a portal experience, but also through Azure Resource Manager. Leveraging templates, or whether you like Terraform using the AZ API provider. Faults are either agent-based or service direct, depending on your target resource type. And with service direct providers, you're able to directly execute experiments to Azure native resources like Azure Key Vaults, Cosmos databases, and network security groups. And specifically for Azure Kubernetes Services, or AKS, if you will, Microsoft decided to leverage Chaos Mesh. And Chaos Mesh is an open source chaos engineering platform specifically for Kubernetes. It does require you to install Chaos Mesh on your Kubernetes cluster. And examples of chaos experiments include pod failures, container issues, network faults like delays, duplications, loss, and corruption. The agent-based provider requires you to install an agent within your virtual machine. And you'll see it as an extension within the Azure portal, just as you are used to with working with like the Azure Monitoring Agent, for example. So we actually covered all the theory right now. So for today's session, I do have prepared 2 experiments. In the first, we're going to cause a pod failure within our Kubernetes cluster. And I'll show you how you can get started by introducing faults into your AKS cluster with Azure Chaos Studio. And if there's time left, I'll show you how to kill a process within a virtual machine with the agent-based service. I'll go through the whole process of onboarding on the AKS demo, creating the experiment and executing it. So once again, I would like to mention that if you want to get started with this yourself after this presentation, you can find an extensive article on my blog or on the documentation website of Microsoft. Both explain step by step of what I'm showing today. In my blog, there's also a link to my GitHub repository with the necessary resources such as the ARM templates. So without further ado, let's break some stuff. There's my screen again. And for today, I am working with a Kubernetes cluster, which is now running the Azure voting app. So if any of you people have ever followed one of the guides or tutorials on the Microsoft documentation website for Kubernetes, for Azure Kubernetes Services, you are familiar with this app. And it's very straightforward app. It doesn't count on the different buttons that I'm actually clicking, and this is like the steady state. It works as intended. If I refresh the page, it goes here. So within that process that I presented earlier, this is actually a healthy, steady state. Going to show you how we are going to actually break it and introduce an Azure Chaos mesh fault or a pod fault. I will be using for beneficial reasons the Cloud Shell today. I will not do it through my Visual Studio Code because I had some problems with presenting that on screen. However, this would do. Let me first get the right subscription. Live typo, nice. So that works. First, I need to get my Azure credentials for my Azure Kubernetes services. Let's pass this one in. And to show you that what I'm running today, I do use the default namespace as the Microsoft Guide told me to do for the Azure voting app. So within that default namespace, it's actually showing me that it's running a front and a back and the Kubernetes service, which actually is the load balancer. It provides me on this external IP, which you can see here, ending on 65. So that's correct. And we're going to introduce a pod fault on the front end because I do want to show you that it is not working, right? So as I mentioned earlier, if you want to introduce faults within Azure Kubernetes Services, we do have to install Chaos Mesh. And because I'm going to run a pod fault, I will do that in an isolated namespace. So let me first create a namespace, keyword control, create namespace Chaos testing. I will install Chaos Mesh by running the Helm install command. I have already added and updated the repo for that, but just for the sake of demonstration, I will do it again. So Helm repo add Chaos Mesh, and then the chart actually that Chaos Mesh provides. You can find all of this within the documentation on the Microsoft website or within my own blog. And we're going to install Chaos Mesh by running the install Chaos Mesh command within the namespace Chaos testing I just created. Let's give it some time. So let's see how it's deploying at the moment. Get pods within the namespace of chaos testing. And you see that it's actually creating a various number of controllers, a dashboard, and 2 daemons for running the experiments. I do not need the dashboard today, but I do need the others. So let's give it just a few more seconds. And there we go. Clear this out. So when working with Azure Chaos Studio, a very important step is that you actually allow Azure Chaos Studio and the resources to be identified and accessed so that they have access to actually run the experiments. If you run into faults in a later stage, you probably have done something wrong by giving enough permissions of running the Azure Chaos Studio experiments. And also within the documentation, there is an extensive article under fault providers of which permissions are needed running which type of resource faults. So today we're running the Azure Kubernetes Service Chaos Mesh faults towards our managed cluster. And the suggested role assignment by Microsoft, which is least privilege, is the Azure Kubernetes Service Cluster admin role. So in the next step, we're actually going to give that permission to our experiment. I do have prepared, and I will show you what's in it already, an experiment. I will demonstrate how you create an experiment, but for the purpose of giving the permissions, I have already created it. And let's first get the ID from this experiment. So Azure AD service principal list display name, which is actually the experiment, and I want its ID. And now I can give permissions the role of Azure Kubernetes Service Cluster admin role to my experiment running the Azure role assignment create. So once again, Azure Kubernetes Service Cluster admin role, and I do it on the resource group level. It is sufficient to do it on the Kubernetes cluster, but for demo purposes and for convenience, I do it on the resource group level. So let's run that one. And it says it's done. So now, just to validate, I have my resource group here, role assignments, and you can actually see that I have given the Azure Kubernetes Service Cluster admin role to my Azure Chaos Studio experiment. The next thing you want to do is, but only after you installed Chaos Mesh, is to actually enable it on the target. So I haven't onboarded the Azure Chaos or the Azure Kubernetes service yet as a target within Azure Chaos Studio. So let's do that now. And you have 2 types, like I mentioned earlier, where the agent base is only for virtual machines installing the agent, and otherwise it would be the service direct target. So let's enable that. And this should run rather quickly. And there you go. Making sure it's enabled. Let's refresh that one. And it actually says enabled for the service direct. Wonderful. So for creating experiments, and I'm doing it through the portal experience, but once again, you can also do this by using ARM templates. Those templates are available on the documentation website or on my blog. But for demo purposes, I will show it through the portal experience. And actually, when you create an experiment, you will need to fill in the metadata from which subscription and resource group, which region, and and then you go to the experiment designer, and I will show you the experiment designer through the experiment I've already created. So let's edit this one. And this is actually where you can create your experiment, where you will do a sequence of tasks or parallel tasks, and you can even add some delay between the various steps and faults and actions you are introducing. However, just to keep it simple, I will do only a one-step fault today, a one-step action, which is the AKS Chaos Mesh Pod Chaos fault that I'm introducing. And looking at how Microsoft describes it, they say that it's you need to give it in towards Azure Chaos within Chaos Mesh through a JSON format. And it is very important that you only include the YAML under the JSON spec property. So when we're going to the website of Chaos Mesh, they have an extensive article on their own different faults, which reflect with the documentation website of Microsoft. And there actually is the pod failure examples where you can also customize it on the selectors. So I'm using the namespace selector today, but you can also do it on labels or whatnot. You can all find that in this documentation. But what Microsoft means with only under the JSON spec is actually this part. So when I would want to, let's say, use it in a YAML to JSON converter, I would pass this part in. And only this part is what we need within our Azure Chaos experiment. And that reflects for my experiment here. I made it 600 seconds and I used the namespace selector for the default namespace, where my Azure voting app lives in. And it actually requests you to also use the AKS Chaos Mesh Pod Chaos introduction fault. So this is like where you can fool around a bit for the parameters to customize the impact of your fault. Next, you can choose your target. Well, I only have one AKS cluster enabled, which we did in the previous step. So let's get this one running and see how it works underwater. Let's get my Cloud Shell back up. Come on. There it is. Default. So it's still working. So when I run this, it will go first into a pre-processing state. It will wait a bit and see and check if everything works as intended, if the Chaos Mesh is installed, and then it will actually run the fault towards the cluster as I have customized it within the parameters. So it will run it against the default namespace. And it will do so for 10 minutes because I configured it that way. But you can do it as short or long as you want. So figure for multi-cluster or a high availability concept where you have more than one pod like I have, you might run faults simultaneously or in sequence just to see what it does. And if everything goes as planned, it will go from waiting to start into a running state. There it goes. And this is actually the moment where it is running its pod faults to the namespace. And I already see that when I run, let's get pods. I already see that it is restarting the pods within this namespace, right? So it already had a restart from the pods, and it is continuously running these faults. It's not a one-time action. It's continuously running these faults. So my hypothesis is actually that if I refresh this page, it will not work. And luckily, I have prepared this demonstration and I know it won't work. So it's doing what we want it to do. So we can, by surgical precision, we can actually address this experiment to one namespace only, an isolated namespace. So it's still refreshing. Let's do a hard refresh for demo purposes. Reload. Continue. It really isn't working. It will ultimately it will give me a timeout. So I can do two things. I can let it run and then self-heal, let it run for 10 minutes and then it would self-heal because of the architecture of Kubernetes. Or I can just stop this one. And for demo purposes and time purposes, I will stop running the experiment. It is canceling. So if you run into faults, like I did here, it had a failed state. That actually is because it didn't have the right permissions to execute this experiment. So if you run into faults, the first thing you might want to check is, did you give the chaos experiment the right permissions to execute it? So the earlier role assignment we did with the Azure Kubernetes Service cluster admin role, that's probably the step that you want to check that you did correctly. So it's now in a canceled state. It had two restarts along the way. And if I refresh this page now, there it is. It's working again. So we see its magic doing from the chaos experiment. And I'm not showing you how you monitor this, right? So observability is obviously a very important part of running chaos experiments. I'm only showing you how to introduce these faults. But obviously, it goes hand in hand with creating the right insights so you can verify, learn, and fix the problems in a production environment. So the next thing I would like to show you is running a fault towards an Azure virtual machine. So I have two Azure virtual machines sitting behind the load balancer. And actually, this is machine number 1, and this is machine number 2. And behind port 80, they both listen. So because of the load balancer, we can access both machines over one port. I will actually try to run the experiment to only one machine. Let me check if I already have these machines onboarded with installing the agent. And yes, it is enabled. The agents are enabled. And just to show you that it's actually an extension, let's get this one. Extensions. Here is the Chaos agent. So this is actually an Ubuntu machine, but it also works on Windows. And what I'm going to do is I'm going to kill the Apache 2. The Apache 2 service. And once again, showing you in the portal experience. And these are a little more straightforward, where you just say kill process for 10 minutes, doing it every millisecond and giving the process name. If you do have a virtual machine skill set, you can address it to a specific instance within it. And we're going to run the fault against server number 1. So that's actually with the black background. It's this one. And I will also run. Now, let's just first get this one started. And I will show you that the Apache service is actually not running on the machine. So let's get it running. It's pre-processing. and it's in a running state. And if I would refresh this page, it would only refresh. So just to show you that it is broken, it's actually broken. Oh, nice. It's in a failed state. So it's a fail in a demo environment. Let me check what it is actually. Unable to find healthy agents for the target instance. So not sure what's happening here because I ran this demo yesterday and it worked fine. I will not go to troubleshoot this within my presentation right now. But once again, you can find an extensive article on this on the Microsoft website and on my own blog. And feel free to reach out if you want a one-on-one demo of that. That's no problem, but I will not troubleshoot it at this moment. So going back to my presentation, besides Azure Chaos Studio, there are many other chaos engineering tools available, both open source products as well as from reputable companies. And I won't go through them all one by one, but they each have their own characteristics, and it's advised to select one based on your requirements before you adopt the tool and start building and running chaos experiments. And for the Azure native software engineers, most of you will have Azure Chaos Studio as the preferred choice, but specific requirements can lead to other chaos engineering tools based on specific needs. And ultimately, the tool will just be a resource to reach your goal faster and easier, which is, in our case, achieve greater resilience. And on a side note, QB Doom is probably the only valid and supervised approved reason to play Doom on your day-to-day job. So that might be interesting for you. So check that one out for sure. And I would like to end with summarizing what I covered in this session. And that is that service levels of subcomponents have an impact on the resilience and availability of the total solution. A 99.99 availability guarantee for a virtual machine does not mean that the entire solution is 99.99% available. And as a developer or IT pro, it's up to you to do your homework on this and do your math. And following DevOps methods, we are all responsible for the quality of the products and services that we build. And that also goes for resilience. So building resilience is an obligation, not an option. Chaos engineering, when properly organized, makes the weaknesses in solutions visible so they can be remedied. And when a chaos experiment reveals a weakness, it's actually worth celebrating rather than blaming anyone. There is a difference between chaos engineering and intentionally disrupting production systems, because nobody wants a developer or IT pro to take a hard look at systems during peak times. Chaos engineering requires coordination with business operations, devising deployment models such as canary deployments, taking care of intervention scenarios, and minimizing the blast radius. Chaos engineering is not only for the business, it's with the business and requires planning and collaboration. So align the process and the working method and implement a continuous improvement and retrospective process with the business. With Azure Chaos Studio, Microsoft has offered us an Azure native chaos engineering service, equipped with almost everything we expect from an Azure native service. So like the integration with Azure role-based access control and ARM templates make it a promising service for developers and IT pros. Mostly for the IT pros and developers that are already working with the Azure BIOS system. Although it is still in public preview, we can expect more development in this service from Microsoft. And lastly, a fool with a tool is still a fool. Find your tools for the goal you have and to get there as quickly and efficiently as possible. There are many tools out there, all with their own characteristics. And if Azure Chaos Studio fits your requirements less than another tool, then you should go with the tool that matches your requirements. Start with getting a clear view on what you need. And then I come to an end of my presentation. Thank you so much for listening. Do we have time for questions, Dwayne?
We do, but I don't see any in any of the chats, so I don't think there's any questions. you got visited by the demo chaos demons today.
I did.
Unfortunately.
Luckily, I prepared 2 demos, so you actually got to see the magic of Azure Chaos Studio. But however, in my environment, it didn't work today. It will probably work later this afternoon. But you know the drill, right?
Yeah, typical to the cloud. Yeah, when you want it to work, especially when you're showing somebody, it's not going to.
No, absolutely.
Well done. I like the fool with the tool is still a fool. That's got it. You're only as good as the person behind the curtain.
It is, and it has to fit its purpose, right? So it is the people that are actually working with it, but it's also that there are tremendous amounts of tools these days, open source or non-open source, and one step that we somehow forget sometimes is actually doing our requirements analysis before selecting a tool. So if you work only in Kubernetes but not in Azure, you could look at other tools if they fit your needs more than Azure Chaos Studio, which is a public preview offering. So no reason to go for the Azure tooling at this moment, looking at other open source options.
Definitely. That's whenever I'm talking about any kind of development or anything, it's all about planning and knowing what is the end goal. You got to understand that before you get started, or you're going to set yourself up for a failure. So well done, Rolf. I want to thank you for taking your time out for the Cloud Lunch and Learn today. Hopefully everybody that watched the live stream learned something new today, as well as everybody that's watching the recording afterwards. I know we get a lot of traffic on the YouTube channel for these sessions, so I'm sure Rolf would be more than happy to answer any questions that you might have if you rewatch this or you're watching this for the first time. Feel free. He's been great to provide his social media, and check out his podcast. I'm going to have to do that as well. So thank you very much, Rolf. I appreciate your time today.
Absolutely pleasure. No problem. Thank you for having
me. So with that,
I
want to just tell everybody thanks and have a great day. And until next time, continue learning. And thank you from the Cloud Lunch and Learn team.